Hello, this next module presentation is going to be about pipework and getting the specifications right. This is a joint presentation with Crown House and Tata Steel. I will do the first part of the presentation. My colleague Irek will deliver the second part. Both of us have been heavily involved in building services for many years, and we've worked very closely together on a number of projects. So we thought it was a good opportunity for us to showcase some of that work which we've done together, and also to highlight some of the issues which we constantly see with regards to building services and pipework specifications. Irek will introduce himself later on when he enters his section. However, lots of experience, as I said, in pipework systems and also compliance. Myself work for Tata Steel Tubes, and again responsible for building services, and again heavily involved in pipework specifications and also looking at compliance. So we thought this presentation would be quite useful to really talk about the importance of pipework specifications, and also to try and explain the differences between carbon steel tubes. This can have a big impact on application suitability of products, and also whether these tubes are able to be successfully utilized when in service. So if we look at why pipework specifications are important, I think it's safe to say that a lot of people, when they see pipework on projects, just assume that all the tubes are the same. Unfortunately, they're not. Tata Steel manufactures a whole range of different products, and we work very closely with a number of our competitors, so we do understand the differences between carbon steel tubes. In this presentation, we're talking about what we call thick wall steel tubes, and again, there are different manufacturing methods which can have a significant difference on how those tubes then perform and operate in service. And unfortunately, we have seen numerous cases where incorrect specifications have been referred to, and this has allowed wrong products to be used. We see a tendency of legacy pipework specifications being cut and paste from previous projects. And I think it's also safe to say, because of the increase in tall buildings, we've seen the diameter of pipework increase significantly, and this has resulted in what we call industrial pipework specifications now being referred to. We also see a lot of misunderstandings and legacy industrial requirements being asked for. So again, unfortunately, we do see mistakes being made, and hopefully this presentation will allow us to highlight some of those issues. I think it's also safe to say that building services is becoming a lot more complex. Certainly over the last sort of 10 years, I've been involved in looking at the specifications and application specifications in detail, being able to see a significant change in some of the demands that the pipework systems are being put under. This is still work in progress. It's a piece of work which has been done by BESA and other trade associations to try and characterize typical applications. But what it does allow you to see is, when we talk about temperature ranges, building services pipeworks may be exposed to temperatures as low as minus 30 degrees C or as high as 200 degrees C. And again, when we look at the type of pressures which the systems could be exposed to, again from millibar up to some pressures well above 100 bar. So again, making sure that the pipework specification is correct is vitally important to ensure that the right product is installed in these applications, which might have quite high and demanding temperature and pressure applications. When we talk about legacy, I think a lot of people still make reference to BS 1387. This is the go-to standard for what was the old building services tube. Unfortunately, it was withdrawn in 2004, so it's an old, outdated specification. And it also only goes up to 6-inch in diameter. So again, when we see specifications asking for large diameter tube greater than 6-inch, this particular standard, then we know that that's not correct. Those products don't technically exist. We also see a lot of people making reference to what we call the API industrial project products within their projects. And this comes about, again, from legacy. In the old days, when people wanted larger diameter products, the only thing which was really available in the UK market would have been the types of American line pipe tube which were being used in the North Sea. So that's why we see terminology mismatch, with people asking for medium weight or heavy weight, or shed 20 or shed 40. And again, we see a combination of different requirements on projects which actually doesn't really make technical sense. We sort of understand what the client is asking for, but because he hasn't really defined it correctly, it also means that other people can misinterpret it and different products can be supplied. We also do see a lot of reference to the old legacy British standards, the 3601 and 3602. Again, they have been replaced. So again, every time we see that on a specification, we know that somebody hasn't really acknowledged the fact that those standards are no longer valid. And it's vitally important that people recognize that these standards have been withdrawn, because they've been withdrawn for a reason, because technically they weren't suitable, or they didn't cover compliance, or they didn't have the right size, or they didn't have the right protocols in place for validating against European directives and harmonized standards. So legacy specifications are really dangerous if they're still in your project specs. Unfortunately, it's not just a simple case saying, okay, I've made reference to 1387. What is the replacement standard? Okay, BSEN 10255. That's what I want to basically make reference to. Because the problem is, all the replacement standards tend to have a lot of other manufacturing options and what we call technical delivery conditions. And this means if you just specify on standard, actually defining what it is you actually want, there's still the risk that an alternative or a different product could be supplied. And it may be that the first product you use is suitable, but it could be that other products which are supplied at later dates could be completely different, therefore behave differently, and if they're installed in the same system, runs the risk of having sort of cross-contamination, as we call it. So you can see most of the standards either have a welded or seamless production option and can be supplied in either a cold form or hot finish condition. And we'll talk about this a little bit later on in the presentation. The other thing which is very important to notice is most of the standards which we now work to today as a tube manufacturer actually come with a variety of different grade options. And most of the specifications we see don't tend to really highlight what grade is being referred to. Now, this is important if you're looking at pressure integrity, because again, the stronger grade of steel, the higher the pressure integrity is. But also, if you specify grades, you can also then obviously look at weight savings by having thinner walls. You can look at defining the technical delivery conditions exactly, so you know what sort of compliance, whether the product is suitable for what we call ambient temperature or elevated temperature use, and also what type of harmonization it has with particular standards and Euro norms, and what type of certification and testing protocols will be followed as well. So just specifying 10255 by itself is defining loosely what you want, but you can see without specifying whether you want a welded tube or seamless tube or what type of grade or technical delivery condition, there's still a bit of a question mark with regards to what you're actually going to get delivered to site. Now, it's important when we talk about the differences between tubes because, as I said, the manufacturing methods do produce different characteristics. So we're going to talk roughly about the differences between manufacturing types and then the technical delivery conditions. So when we talk about the manufacturing types, obviously seamless is historically seen as a product because it tends to be thick walls. It's actually produced by taking a billet, heating it up and extruding it, so it tends to be seen as a fully normalized hot finished product. Whereas historically a welded tube might have been seen as being weaker because there is a weld seam in place. However, when you look at the manufacturing process for welded tubes, there are actually two different types. So the first option would be a cold form tube. So this is where instead of using a billet like a seamless mill uses, we take a coil of steel, we form it into the tube profile, we use a high frequency induction welder, which means it superheats the ends of the strip and we squeeze it together. There's no filler material used. That then basically produces a cold form tube. We then take that tube, which has a heat affected zone, a weld seam, and we actually put it through a furnace and take it up to temperatures of about 1000 degrees C, which allows that weld seam to basically disappear. So a welded tube can be seen as being equivalent to seamless only if it's gone through a heat process, a normalizing process. One of the advantages that welded has over seamless is that a welded tube, because the way we form it, we have very tight control of the tolerances. So when it comes to ovality and consistency of wall thickness and end matching, a welded product will always be seen as being technically better than a seamless tube, which unfortunately can suffer from out of roundness and inconsistencies on the wall. However, we know that because of the manufacturing process route which seamless follows, because it's being extruded, its grain structure is aligned better to that within a welded steel chemistry, which means that a seamless tube can be able to withstand higher temperatures than a welded tube. And also, because a seamless tube can be extruded, have the thickness on its walls, so again actually satisfy higher pressures. But in most building services applications, we tend to see that a welded tube, as long as it's normalized to part 2, a hot finish, will be able to take temperatures up to 300 and 400 degrees C and quite high pressures. But certainly there's some industrial applications where we would recommend that a seamless tube gets used. The big difference to highlight when people don't specify the tube specifications correctly is this hot versus cold form. So the welded process route, everything starts off as a cold form tube. And you can see this heat affected zone. You can see the area where if you cut through the tube, we have this sort of discoloration. This is because the microstructure in that area has changed. It's distorted. So it's very brittle. And we have a hardness area across there, which is different to the rest of the tube body, which may also be experiencing stresses as a result of the forming process. By normalizing the tube, we actually remove all that stress and realign the structure, the microstructure of the steel. So basically we end up with consistent properties. It also means that the product is more suitable for higher temperatures, it's suitable for pressures higher than cold form, and more importantly, because it's been normalized, it's also able to resist the initial onset of corrosion and can be manipulated and fabricated more without increased work hardening and failures. Again, we've worked very closely with the market and analysed the different products in terms of cold form and hot finished, and we've got a number of advantages which we can promote with the technical solutions that hot finish offered, and we've seen this time and time again. So this is why it's vitally important to ensure that when you are specifying a product, you're specifying it correctly, so then you can see that either a seamless or welded or hot finish or cold form has been correctly identified, because it does make a big difference when those tubes are being used in service.
Thank you, Chris. Second part of the presentation is about the challenges facing projects and how we can mitigate risk associated with wrong pipework and material selection. My name is Irek, and I'm a technical manager for Crown House Technologies, looking after various aspects across all projects. So the challenges on our projects. So the first challenge would be always the consultant specification and internal specifications. So starting point for every project is a project particular specification. And in many cases, we can still see that consultants are specifying or referring to BS 1387, which was basically withdrawn in 2004, or only referring to EN 10255, which basically is too generic to define exact pipework manufacturing process and technical properties of this tube. Referring only to EN 10255, it is like telling basically to a car dealer that you want to buy a car, but you don't give him any more information. So you can only imagine how many different types of cars or models are available on the market. So providing only the general standards create a risk that provides the opportunity to supply various types of products, not necessarily suitable for particular applications. And the example we've got here from one of the projects where consultant specification asked for BS 1387, basically incorrect. But the requirement was that pipework needed to be suitable for elevated temperature, which is greater than ambient. But obviously, if as withdrawal standard was referenced with no other information in place, the supply chain referred to EN 10255, but unfortunately defined the cold form tube instead of hot finish, which obviously the cold form was not compliant with the project requirements. Example of incorrect standards that we came across on our projects. So the top table is incorrect standards being used with lack of clarification, where you can see that, again, consultants still referring to BS 1387, and on the top adding some German designation, and again, EN 10255, which is incorrect and poor standard kind of definition. We got example that people believe that they can define right standards for tubes, but obviously they can't. And what they're trying to do in these situations is that they're trying to put as many standards as they know, and they think that they will be covered with any possible options. The top table for largest sizes is referring to the DIN EN 10220, which is not even tube manufacturing standard. So in this case, is a dimensional standard which is incorrect in the first place. So the bottom green table, it is showing the correct defined pipework standard after verification with the specialist. And what we've got here, so we've got a full description of the standard that pipes should comply to. So it's BN-ES 10217 part 2, which is hot finish. Then we know there's EN 10255, which is not alloy steel, pipe suitable for welding and threading, and specific temperatures by defining the correct grade, and also information about the CE mark to cut 3. And for the larger sizes, obviously similar description, or simple, we can define to the Tata steel product, which is 236 or 265, which comply with both requirements. Just coming back to my example that I gave you on the previous slide. So if we refer to a car example, the top table, you can only imagine that someone is coming to the car dealer and asking, I want to buy a car, I've got £10,000. But basically, if you refer to the green table, it's telling you exactly what you want. So for example, you want BMW, it is X1, it is white color, is it petrol, is automatic, upholstery is black leather, and alloy wheels. So you know how many details you can go through. And by defining the general standards without defining the detailed information, it puts you in big risk. Other big challenge is the supply chain. Basically, general lack of understanding of materials and applications. There's a huge skill gap within the industry, with lots of people leaving the industry. And we rely many times on supply chain to select the right product. So if there is no expertise within this particular, part of industry, we are in huge risk. Decisions most of the time are driven by also cost reduction and variety of alternative products available on the market from international suppliers. In general, poor awareness that such alternatives are not always manufactured or tested to any current British or European standards, or have to the required traceability or consistency. And again, we've got the example with one of the projects where specification was to BN 1386 and supposed to be used for gas. So there was the requirement for the declaration of performance, a CE marking to cut 3, which is under the fuel and air and gas requirements. But this was not clearly communicated, and unfortunately non-CE mark material has been supplied to a project. Installer obviously had not realized this, and so many different tubes has been supplied to the job. So made traceability and addressing quality concerns a huge challenge on this particular project. Another 2 examples of supply chain found on the internet are quite current. So there are the medium, I would say, size distributors available on UK market. They are offering carbon tubes to our projects. And the left example, you can see that purely this supply chain, this particular distributor is referring to standard BS 1387 and stating that the pipe diameter is 300 millimeters. That is even not correct, because BS 1387 never went up to the size. Also, basically, the grades stated below the pictures, which they refer to different grades, cannot be achieved under BS 1387. Obviously, again, they are referring to the size to DN 200 and above, which is not covered under BS 1387. So we can see the huge risk that could be put on any project if they supply basically the pipework from this particular supplier. The other example, again, is the BS 1387 galvanized steel tube. where the distributor highlight every possible system from the construction industry that this pipe is suitable for, and on the top, basically adding every possible certifications available in the industrial market to certify the pipes, which obviously is incorrect. He is referring to the American standards. CE marking, obviously you can't CE mark BS 1387 and so on, and other Japanese standards, which is kind of really worrying that what kind of tubes are reaching our projects. Subcontracts. So in many cases, the main contractor rely on some small subcontract firms when there's a big project, basically. However, due to lack of awareness or to take advantage of generic and flexible consultant specifications, mostly time cheaper and alternative and incorrect products are being used. And this particular example, when we got when the technical specification or specification for this project was correct, so stated the correct tube, but obviously due to a subcontractor, the specification got diluted as part of the project subcontracted out, basically. Alternative material was imported as part 1, which was cold form, and not part 2, which was hot finish, and it was required for this particular project. Tube documentation did not match the project specification during final QA checks, and unfortunately has to be removed and causing huge delays and cost implications to this particular project. The other example, as I said previously, the large projects, sometimes the pipework packages got split into a number of different subcontractors, and we see that on one project sometimes we might end up with 3 subcontractors doing one pipework package in different project zones. So in one particular example, you could end up with 4 different pipes coming from 4 different markets, which none of them are compliant to our projects, but there is the light in the tunnel, and some companies are definitely aware of this issue and getting things right by defining exactly pipe specification at the design stage before it's procured. The next point is the solutions, how we can mitigate this risk, basically. So as Crown House, we've been working quite intense with Tata Steel, and we developed in-house minimum requirement specifications to ensure selected tubes are compliant to current standards. Those preferred product specifications are then submitted to a consultant and client as our offering. So basically, it is sort of a reverse engineering when we are telling consultant and client what we want to use to build the system. And we know that we prove this components, this particular project, and we know it definitely work. Also, Crown House developed a list of preferred manufacturers and suppliers that can be used on our projects. So normally we have a list of preferred and approved suppliers that is constantly updated, and every new product needs to go through internal technical review before reach this list. And basically needs to be accepted in order to be allowed on our projects. So as I mentioned before, we develop the set of in-house engineering standards. This particular one that you can see is a specification for a carbon steel. And the difference is that we are providing specification for the system. So it's not only tube, but within this document, you can find information, anything for the grade of bolts and nuts used, going through the washer, flanges, the valves, even which are compliant with this particular system, and obviously with the correct pipework specification that can be used on this project. So is the definition of the system rather than trying to define sometimes independent components that not necessarily can work together. The other set of documents, so on the top of the engineering specifications, we developed the technical submissions, which are again very detailed and are verified prior to use on any project. So they are the generic standards. And within these technical submissions, we are going through we are going into the details exactly about the pressure rating and all technical parameters of this particular, in this example, tube selected for a project. Also, we tend to issue quite often bulletins that give updates to our different teams on the projects. Restrictions also apply to our subcontractor working on our sites. So basically, they need to follow our internal standards, and CHT internal standards are part of the contract with our subcontractors. By minimizing number of suppliers and manufacturers, we are enhancing relationship with supply chain and mitigating risk of using unapproved materials. As an example, we are working with 4 main distributors, and they are really aware of our projects and our standards. They know what we've specified in this example for a tube. And we had few times the phone calls from that telling us that our subcontractor is trying to purchase cheaper and not compliant pipe for our projects. So basically this awareness is quite beneficial for both sides, because they are the one distributors who are educated with our standards. They can stop really at this level to supply incorrect pipes to our projects. As a group, Crown Health Technology policy is to only use traceable products. So by correctly defining what we want to do. Solutions to mitigate the risk. Other measures can be implemented to our projects or to our teams. What are the site inspections? And training is really vital. So training not only to site teams, which I believe is really too late to reach, but also side to our procurement. And working alongside material specialists like Tata Steel to ensure the compatibility of materials used within our systems is correct.
So just to conclude, obviously I'm conscious of time, but there's obviously quite a few things we've talked about, and I know there's some people got some questions, but we'll take those offline. But basically what we wanted to try and get across today was the fact that pipework specifications are important. Mistakes have been made. However, working closely with industrial partners such as Crown House, we've been able to put in place procedures and policies which allow us to reduce that risk of incorrect material being used. We're not saying that materials are not suitable for particular applications. We're just saying that you need to define which are the correct materials for particular applications where pressure and temperature may be an important factor. And we've been doing a lot of work with BESA and other trade associations to try and improve the awareness of this issue. And the BESA Pipework Technical Committee have been meeting and working on a regular basis. And we hope to have some exciting news to roll out next year about some guidance documents and some pipework selection tools, which will make it a lot easier for people to understand which is the right tube specification for their particular jobs. So I'd like to thank you for your time. And like I say, if there's any questions, then obviously our details are being circulated, and we'd both be more than happy to take this offline and to discuss with you at a later date. Thank you.
Thank you very much. Thank you.